Hey, welcome to 16-Bit Bench, Matt here. I'm stuck at the moment waiting for parts for a couple of the projects we're working on, like the SNES handheld and some other things. So I needed to find something to do. So what we've got here is a relatively beat up Mega Drive. Looks like model 16109, I don't know, is that an early model? And what we're going to do is refurb this and switchless mod it. So if you don't know, you can mod these very easily with switches. You can put one or two switches on the back here to select regions and refresh rates. So you can have your console. This is probably a PAL console. Hey, this video is nearly an hour long, so if you're interested in these points, these are where you need to jump to. So yeah, let's head back to the action. Probably. I think it's a French RGB model, like most of the stuff I've got at the moment. Yeah, so it will run 50 Hz PAL, which means the screen is squished in and it's about 20% slower than it would otherwise be. So you can switch it into 60 Hz PAL mode, so you still have the PAL image, but it's now refreshing at the NTSC screen rate, and that means you get the full screen size and you get the correct speed. And you can have a third mode, which is 60 Hz PAL Japanese language. So you can play the games, almost all the Mega Drive games, and here's an example of what a Mega Drive game looks like. Have English and Japanese in them, and it's the console that selects which region it's in and which language it's going to display. Okay, so this guy's pretty filthy, and I just tested it and it doesn't seem to be reading the games, so it may need a clean or a recap. So what we're going to do first is take it apart, and see what's going on inside. 6 screws on the bottom. Okay, unscrewed, 6 screws. What I'm expecting to find is that we need to maybe recap it or resolder the RGB port, so we'll have a look. So if you can see, the LED, the indication LED, is on this weird connector, and this is standard in the Mega Drives that I've opened. So what they do is they just slide it over the pins and then bend it back, and so this pin is red. And what I'll do is find a pen, find a Sharpie that's somewhere on this pigsty that I call a bench. There we go, a pencil. Then I'll just mark on the case where the red side goes, so then I know. And you bend the legs till they're practically straight, and this guy will just slide off. Come on. I mean, I personally think this is a shit way of achieving what they tried to achieve. Really, there we go. The LED should be mounted on the board and a light pipe come up, and that's what they do on the Mega Drive 2 and the Mega Drive 2. Okay, so we don't need this bit. It's relatively beaten up, but we can polish these scratches out, so that's not the end of the world. What revision have we got? Can't tell. I'm not an expert at these things. I haven't opened many of these ones up. Been working on a lot of Mega Drive 2s just because they were top of the pile. So we'll have to go all the way into this guy and figure it out. I don't feel it's a particularly early one, but maybe it is. Who knows? What I've been doing on a lot of these consoles is replacing the regulators. So they have LMO 5-volt linear regulators, and they work by burning all of the unused voltage. So typically the power supply supplies 9 or 10 volts, but the system doesn't really need all that voltage in most cases. Sometimes it may need a negative voltage for the video generation, because if you don't know, video sync pulses go negative. But that can often be done with some circuitry wizardry, and you may not need a negative voltage, but sometimes the designers do use a negative voltage. But most of the time, all it's doing is taking that 9, 10 or 10 volts and just throwing half of it away. So a lot of our electronics from this era are really inefficient. Electronics have only got much more inefficient in the last few years, and you see that with things like your iPhone charger. You know, very small plug doesn't get hot. It's because it's got a switching regulator in it, and it's basically, it's almost like it sips from the mains voltage. It just takes little nibbles of it. What the power adapter for these guys does is take the whole mains voltage and then squeeze it all the way down to 10 volts, and then feed that into your console. And then it's taking that 10 volts. It's saying, "Oh, I only need 5," and it's burning 5 volts off as heat. And all of that heat is being generated in your transformer, in your power supply, and then inside the console, and everything's getting warm. And then also your chips are getting warm, because that's what chips do. And really, all of this shit was super inefficient. What are you looking like? Take you out. Oh, lost him. It's early on a Monday morning here at 16 Bench Towers and 16-bit Bench Towers, and I'm fucking knackered as usual. I think I might have to just bend that. So let's do that. Let's give that a little bend. That lifts most of that up, but this guy's still staying. I think that's where some kind of heat sink there on that. There's you can't see, you know, I've moved it. There's a gold screw, and this pink stuff is thread lock to stop things getting unscrewed. There we go. Yeah, and you can see there's a big heat sink there. Then attached to the heat sink, as I was talking about, are two LM05 5-volt linear regulators. So yeah, you know, this was a very cost-effective and affordable design for the time. But if you were to build one of these now, and if you've seen it, there's videos on YouTube. I suggest you go look at them. Basically, it's a Mega Drive clone, so it comes in the same size case as this, and inside is a small board with the cartridge edge connector on it, and then there's a small board at the front with the ports on it, and then there's a small board at the back with like an HDMI up converter sort of thing on it, and that's it. There's nothing else in there. I always forget the two screws holding the cartridge edge connector down. Forgive me, like I said, it's early in the morning. So there we go. We're free. There's the bottom of your case. A little bit rusty up here. See that? A little bit rusty. Been learning the hard way recently, not to use my 3D printer bed as a storage area, because it throws off the bed leveling, which takes ages. Okay. There is your Motorola 68,000 CPU. Big bastard, isn't it? It's my Yamaha audio chip over here. It's like a Sony video encoder chip down here. Something from Sanyo. A lot of good Japanese names in here. A couple of sharp, probably shift registers for the controllers or something. Here's your Zilog Z80. I think that the Z80 does the music or something. Yeah, whatever. It's early. I can't think. yeah, there's two processors in here, but the Motorola is actually what does the work, and the Zilog is doing something ancillary, which I can't remember. Might even be, I think it might even allow for backwards compatibility with the master system. Okay, so there's some kind of RGB mod here. There's a wire coming off of what is probably an LM, some kind of Sony video encoding chip. So we've got, I'm going to guess that's sync coming in here. So taking a look at the pins, none of them seem very cracked. If you go back in and look at some of my earlier videos, I was modding master systems, and basically the problem was that the DIN connector for the master systems was really fragile and would crack. Now I'm only going to assume that this has the same problem, but maybe this Mega Drive's been treated a bit nicer. Maybe it looks like... So the easy way to check that is get out your trusty multimeter. It's a fucking multimeter, seriously. Ugh. Someone's got a case of them Mondays. This is actually my 8th straight day in the office, because when you're self-employed, you have to work really hard. I plugged it in, got sound out of it, but no video, and then the sound stopped. So the connector is suspect here. It might be that the cable I'm using is not the right pin out, but I think it is because I only have new ones of the Mega Drive cable. So what we're going to need to do is get out the oscilloscope and have a look and see if we can see any video on the pins out, and we'll also pull up a pin out of that connector so we know where we're looking. So that's the next job. Tested it a few more times. I'm definitely getting sound out of this, and that sound is going to the TV, not just out of the headphone socket. So I know sound is working out of here. So if I grab my SCART cable, so you can get these off eBay. They're relatively cheap. It's a Mega Drive or Master System RGB SCART cable. It has a 8-pin DIN connector on that, and that's what plugs in here. But I can't be 100% sure if this cable is compatible with this Mega Drive, or if this cable works or not. So what we're going to do is we're going to probe the outputs of this connector here. So you can see the pins here just in this area with this yellow jumper wire coming up to it as well. This is where we need to look. First thing I did, and you saw me do, was check continuity between these pins on the board. So, you know, it's doubtful that these are broken, but they may be. So yeah, what I've got on the bench is my Rigol DS1054Z oscilloscope. This is a great entry-level scope for fault finding, this kind of stuff. Video is very hard to fault find without a scope. You can't do it with a multimeter. You won't see. You need to see the waveforms. You need to see what's going on. So what we've got here, our first screenshot, is off the yellow jumper wire. And what I can pretty clearly see is it's a sync pulse. So you can see my volts per division is set to 500 millivolts, and it's 2 divisions, so that's 1 volt. There's 1 volt peak to peak on my, what I'm going to guess is the sync signal. Actually, I don't need to guess. Let's bring up a Mega Drive RGB pinout. So this is easy. These things are easy to find. Mega Drive RGB pinout is all you need to Google. On this C-Sync pin, which is going to be pin 7, I reckon. I think this C-Sync jumper is incorrectly installed. It probably worked fine because the original cable for this probably had a jumper between C-Sync and ground, but this is the new cable that I bought off eBay, so it doesn't have it. I'm going to run a jumper between these two pins just to see. Well, before we do that, what I want to do is buzz out the continuity for this pin, see where it lands on the board, see if it's actually connected to anything or we're just getting some kind of crosstalk between those 2 points. So yeah, we'll do that now. Yeah, if you look at the board, none of the components to generate composite video are really present. Like, so I'd be surprised if it does go anywhere. Yeah, 100% as I thought. That wire is not connected to anything. We're completely safe to put a jumper wire between these two pins. In fact, what I'm going to do is I'm going to move the yellow wire up to the composite pin because no, I'm not going to do that. I'm going to put a jumper in. The reason I'm going to put a jumper in and not move the wire is that someone may one day source an original RGB cable for this and want to use it with it. So this will maintain that functionality. I'm 100% sure now that the what is the composite video pin is not connected to anything. The really weak signal that we picked up on it is just crosstalk because of all the video signals. So there's a lot of high frequency signals in this area. Crosstalk is unsurprisingly present. Here we are. There's the jumper, the orange wire that I've put in between the C-Sync signal, which is coming off of the Sony video encoder chip, and the pin for composite video. Now we ascertain that the pin for composite video is not connected to anything. None of the, you can see the pads there, C124 is not populated. That would have been a decoupling or smoothing capacitor between the composite video and ground. And then if we look up on the top here, you can see a gap between the connector and that coil. There should have been a choke there to the composite video circuit. Composite video encoder circuit would have probably sat here behind the RF can. None of this stuff is populated at all. So that pin is completely floating and free. It wasn't connected to anything. Now it's connected to sync. So we've got sync on composite, and that's how most RGB TVs work. So if we come over to the TV and we turn on the console, it detects the fast switching and switches to AV1 automatically, which obviously is irritating. But there we are. There's our gain working. So the problem with this was a two combination thing. This cable, this generic Mega Drive RGB cable, was not designed to work on the French console version that has no RF, no composite video generation. It's completely RGB. It wasn't designed to work on that. This cable was designed to take sync over composite, or use composite as a sync signal even. Well, that's good news, isn't it? Work that one out. So now the console's modded, it will work with any generic off-the-shelf Mega Drive RGB cable. It also, if anyone ever sources the original French RGB cable, the Sega one that came with it and used it, that will also work. So that mod is completely backwards compatible. The composite video pin, completely disconnected from anything. Now it has C-Sync on it. So that's how that's going to work. So that was the annoying part of this. I didn't appreciate I'd have to be doing all that work to get this far. Now we can start doing the fun stuff. So the fun stuff is we are going to switchless mod this console. We are going to program a microcontroller, and we're going to build a little circuit board. We're going to install that circuit board in here, and it's going to use these jumper pins and the reset button to help you switch modes in the console. So that's going to be the main thrust of this video, and that's going to be a lot of fun. So first thing we're going to do is we're going to grab a microcontroller, and I'm going to show you how to program it. So I'm coming back to an old friend that we've used a couple of times for information on a mod. It's Monkey, or Monkey, if you want to say it that way. So what this does is, this is basically a Mega Drive 1 switchless mod, which is what we've got. We've got Mega Drive 1. It utilizes these jumpers on the board to switch between modes. See, Japanese, English, PAL, NTSC. PAL NTSC is not actually correct. That's 50 and 60 hertz. So you'll get 60 hertz PAL out. You won't get NTSC out. But whatever, it's practically the same. Most TVs are fine with it. Maybe some aren't, but what can you do? This is how you mod your console. There's not another option. So this mod, the Switchless mod, uses the Saturn Switchless mod. So it's the same mod, uses the same chip with the same code in it. So from this monkey page, Mr. Monkey page that we've got, it links to the Switchless Saturn mod on knzl.at, and this here is just explaining how the mod works, and the board that we need to build for the PIC. So it's basically a PIC 16F630, which we used also for the Switchless mod in the Super Nintendo handheld that we're building. So on this one, it's basically driving an LED, and there's a smoothing capacitor here. So what we're going to do is build this board essentially. But before we build the board, we're going to program the PIC. So in order to program the PIC, we need to load up the software. Okay, so from this page you can find the link to the hex files we need to program the controller on GitHub. So if we click that link, we come here. GitHub, you just go clone or download zip, download it, there it is. Let's extract the contents of a file, Saturn mod master. And all you really actually need is the hex file. The other stuff we're not that interested in. So I've plugged in my programmer. It's the Mini Pro programmer, the cheap Chinese one that we've got. It's already set to the PIC 16F630 because we used that before. So we should just be able to read the contents of our device. There we are. Read. Yep, and it's reading the chip successfully. That's fine. So now we just open up our folder. Let's just do it this way. There we are. Hex file. There we go. So we've loaded the hex file into the programmer. It's not a very long program. Barely fills 24 lines. Click this P, program chip. And that's it, done. The PIC 16F630 is very cheap. I mean, you can get 6 or 7 for about a tenner. So that's what I did. Bought a few. So yeah, now what we need to do is build the circuit board. Okay, so if you're following the guide, these are the parts we'll need. So I've got my PIC that we've programmed. I've got a little bit of board that we're going to use. It's about 8 holes by 9 or 10. We have a red and green LED that we're going to use to indicate. We've got 2 resistors, one for the red and one for the green side of the LED. And then I've just got any old capacitor under about a microfarad to use as a decoupling capacitor between the power rails on the PIC. So what we're going to do is we're going to drill out the holes we're going to drill the connections we don't need on the perf board. I'm going to do that with a Dremel. If you don't have a Dremel or drill or anything like that, or a tip, that's fine enough. If you look here, the tip I'm using is like a diamond ball tip, which will just take away the copper there. If you don't have anything like that, of course you can just use a sharp craft knife to cut the traces. That's absolutely fine. So if we look at the guide, we can see that we need to drill a bunch of holes to disconnect the left and the right side of the chip so they're not in continuity, and then we need to drill a couple on over on this side as well in order to make it right. So let's do that. There we go, holes drilled. Let's just check it with the trusty old meter so we know that we have disconnected those sides. Okay, job done. So now we've got to do is solder in our pick. I'm using a socket for that, just in case we kill the pick or we want to remove it later for any reason. The socket's easier, so you just put that in so it's either side of the holes we drilled, like so. So we've got 1 row on that side free and 3 rows on that side free, and we'll just solder that up. Okay, so that's the socket wired in. We need to put a capacitor between the plus and ground rails, so that's the top row. Bend these legs back. Pliers, pliers, there they are. Yeah, if I was using a smaller capacitor, obviously that would be easier. Just chop the leads off on these resistors. Done. 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 So now we need to put some links in. Okay, so this is the little tiny board we've made. Goes that way up. Here's our pick. So what we're going to do is put our pick in our board, and then I'll press it down, and that'll be that. Before we do that, we're going to wire up the connections that need to go to the Mega Drive. So we'll do that bit now, and then we'll populate the board up. If you look at the diagram, it's on this side of your little board are all your connections. So the reset button, the 50, 60 hertz, all that stuff. Boom, 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 boom. So we need 1, 2, 3, 4, 5, 6 colors, and I've got 1, 2, 3, 4, 5, 6, 7. So use the helping hands. What we're going to do is strip the wires and tin them. Okay, so that's the wires for the connections done. Sorry guys, I keep working too far up. Let's move the camera. Hopefully that's a bit better. So all I've got to do is just snip the excess off, and then there's 2 more wires for 5 volts and ground. You don't need a lot of wire. I'd say about 20 centimeters for each wire, because you're not running them very far within the console. If you do a switch mod, then you need more wire because you'll have to run out to a switch on the side of the console, obviously. But here we can put everything pretty close to where it needs to be, so we don't need to worry too much about that. Just tin this wire. There we are, nice and neat. Isn't that cute? Yeah, so the next step is we're going to need to install the LED, and we're going to need to run the wires to where they need to be. So let's go grab the Mega Drive board and take a look at that. We're looking at where to position the chip on the board. I'm thinking pretty centrally is a pretty good idea. So most of the wires have to come down to these jumpers over here, but the reset control wires need to come to the reset button and probably the other side of the board. So we're reaching both ways. Power and ground can be had all over the place, but the easiest spot is actually on the jumpers. There's 5 volts and ground on the name side of the jumper, so where it says, that's where 5 volts and ground are. So yeah, we'll hook it up there. I'm going to hot glue a bit of non-conductive foam. I'm going to stick you right there. Then on our board, we'll just do the same. Pick hot glue, and we'll plop that chap on top of that foam. Okay, so now all we need to do is follow the wiring guide on the guide. and then we need to install the LED. The LED actually goes in the upper case. I'm gonna use a disconnect for the LED, which is something they didn't use on the Mega Drive. Here's the original cable here. There's no proper disconnect that. We don't need that cable anymore, so let's just snip that off. Okay, so I appreciate that Monkey Guide is a little bit confusing because he's chosen not to relabel everything from the Saturn setup, but still we can work with that. So orange wire will go over there. We don't need to worry about that at the moment. 50-60 Hertz selector is my yellow wire, and that needs to go to either side of pins here. Let's go under this wire. And that's about as long as we need to be. Snip that. We'll take a little bit insulation off. Tin the wire. There we go. That's the right wire. And then what? The language select is jumper 10, which is the second to last cable, so that will be my purple. I've realised some of these wires I've soldered in I don't actually need. Okay, and then five volts and ground. Ground obviously is that one because it's going to the ground plane. 5 volts will be that one. So didn't solder the wires for the LED, so I have to do that separately. So I ran into a bit of difficulty doing this. One was I filled the camera up because I've been waffling all morning. It's now about 1 o'clock in the afternoon, and I've been doing this 2 hours longer than I really wanted to. I wanted this to be a nice quick one. So there's a problem with this board that we made. And there's a short on it somewhere. But I'm not sure where. But it doesn't matter, we don't need that. So yeah, I decided to go with classic kind of dead bug configuration. So we've got the pick glued to the board on a bit of foam, and then we've just mounted the components to it and then wired it up that way. It's a little bit messier than I would like, but I think we're okay. Let's just separate out the resistors for the LED. So it's working as intended. Right now it's green, so you hold down the reset button, it'll go into mode select, so it changes color: red, orange, green. I'm not sure if you can tell the difference between orange and green on here, but when it's in the console it's more obvious. Yeah, it doesn't really work at an angle, but when you look at it straight on it does. Yeah, so what you want is when you're on the mode you want, which is 50 Hertz, 60 Hertz or Japanese, you just let go of the button and it will blink and say that's the mode you're in. Yeah, in red mode, whatever red mode is. I'm gonna have to plug it in to work that out because it does, you know, depending on how I've got the LED wired, that would change, and that can be changed quite easily if I want to. But to my mind, it doesn't really matter as long as you know what the colours mean. Yeah, so that's the mod installed. So all we've got to do is put the Mega Drive back together, fit the LED in it, and then we can look at cleaning up that case because that is a state. Right, so we've got our mod installed and we've got our LED poking out the top here. What we need to do now is install it in the top case. So the old LED is here, you can just see it here. And the way that's held in is it's underneath the ring, this shiny ring here that's in the top, and that's held in, just kind of plastic welded in. So in order to remove the ring, we'd have to break all these plastic tabs. I don't want to do that. What we can do is just snip away at the back of the LED and install our LED directly into there, and that's what we will do. What we want to, and then we'll just hot glue it in, hold it in. So we just need to snip away some of the plastic at the back here. I mean, yeah, I like to do mods that are non-destructive whenever possible, but sometimes you know, you've just got to drill holes in cases and pull things around. Yeah, snip a bit more out. And if you really wanted to, you could take a soldering iron to this and melt the plastic, but I don't. That's definitely not what I want to do. Let's just move this out of the way. Where is my, you know, I'm just getting so old, I can't see anymore. I can't even. See if we can pull that out. Oops, just pull the leg off. Oh no, I killed the LED. It's a crap about some 20-year-old red LED anyway. But it's not original anymore. It's not worth as much money. You know, these consoles are not worth that much. Like, people want mint in box, right? So if you don't have mint in box, which most people don't have, because most people get these things when they're kids and throw the boxes away, then no, your console's not worth money. And all those people on eBay who are trying to sell things that are untested or, you know, don't have the cables for it anymore and still trying to get full price, it's ridiculous. Dusty. So now we can install our LED, but I'm not just going to glue it right in because it's wired up. So I want to have a disconnect. I've got a lot of these 2-pin disconnects, but obviously it's a 3-pin disconnect. Yeah, I mean, one of the most irritating things about taking consoles apart is when things aren't made to be taken apart. So then you've got quite a problem. Right, so there's the hole that we've dug. Let's pop our lovely new LED in that hole. Take our hot glue gun, which has been just gently cooking over here for a while. Put a big blob of hot glue in there. So that's our lid with our LED installed. Let's plug that in. So that's what it's like. That's what it looks like inside. You've got the cables there, and all these do is just neatly kind of curl up and sit there on the top. So now they're out of the way. Okay, so what we'll do is just test it as it is and see how that looks. Okay, plugged in, turned on. There's our orange mode. That's green mode. It's kind of difficult to tell the difference between them, really. What I might do is come back to it and put a lower value resistor on the red LED, then it would be brighter. Yeah, you can kind of, or maybe a higher resistance on the green would probably make more sense. So you can see the red is much dimmer than the green. Like the green, actually kind of hurts to look at. It burns your retinas. Pretty. Oh, can't see anything now. Yeah, so we've got a 210 in there, maybe like a 330 on the green LED. I might do that now while it's still not put all together. So yeah, I'm going to go back and change the resistor on that green LED. Okay, so we're gonna clean the top here. And what we're gonna start with, what I've started with is is just as simple as a toothbrush and some window cleaner. So we just put a bit of that on, and I've already started really. I just go before, but I just use the toothbrush to get off all that surface dirt. And one of the things that's really, you really get dirty on the Mega Drive is down here on the volume slider. It just fills full of dust. So what we do is we get cotton bud and down in here, or wipe out some of that dirt. I don't know, can you see how dirty that is? And on the power switch as well. And we'll just do the detailing, and it's just around here, in all the nooks and crannies. Yeah, and the worst bit is this vent here on the side. It's impossible to get in. Look at that, look how filthy that is now. Something a bit spongy, help me get in these holes. Sorry for the noise, I've got the window open. It's got warm. Who would have thought it? It's, you know, it's the middle of June and it's actually warm outside. Shocking. Okay, so this one's not in prime condition anyway. We could go all out and do a full restoration, but I'm not really at that point with this one. It's got a lot of paint marks on it, maybe wall marks, these scratches, which look to me like it's been bashed against a white painted wall, you know. So they could be easy to get. So you get one of these. This is a magic sponge. It's like a stain remover thing. It's kind of a weird abrasive sponge. So what it's going to do is it's going to braid off these marks and then show the sort of plastic underneath. You want to be careful with this. Oh, yeah. It's the LED thing. You want to be careful with this. If you go crazy, especially on painted areas, you're going to wear the paint away. This is abrasive. It's not, you know, it's not actually magic. It's not, you know, growing plastic. It's basically like a very fine grit sandpaper. So if you take it to shiny plastic, and that's this plastic here particularly, it's going to dull it. So you've got to be careful. And this one's not really got much to lose. It's already pretty marked up. Can also help is getting it a little bit wet, just like wet and dry sandpaper. I don't think this mark is gonna. There's a big like Harry Potter lightning bolt here. I don't think that's gonna disappear. But we can knock it back a bit, and that's. I think we've got away with that. Then there's the marks here as well. So I'll try those ones. That's most of the work done. It's now all covered in powder, so give it a brush. Alright, so we've still got a little bit of a problem. There's these white marks now where things have settled. So this a really good way of getting rid of that kind of mark is with this stuff. So just be really frugal. Don't get it and go no. Put it on your rag, whatever you're using, bit of paper towel. That's enough. And then you just buff it into the surface, and it sort of just seems to restore plastic back to the way it should be. That's a pretty good job. It's way cleaner than it was. It's now got this nice sort of dark luster to it from the WD-40, all the white marks that are around here. and the big scratch on the back. It's still there. I mean, you can still see it, but it's not white and obvious anymore. All the paint marks of where it had been dropped or something are all gone. So that is it. That's the restoration. I think that looks really good for something that it was. Remember, this wasn't mint, and I don't want to return it to mint. You could go totally crazy, right? You could dip it to strip off all the paint. You could then reapply the paint using transfers. You could completely disassemble it. These bits can all come out if you remove the plastic tabs. They're all kind of plastic welded in. If you remove all these bits, you can take this whole thing to pieces. You can go crazy. You could recarve polystyrene inserts and rebuild a box from scratch. You can go as far as you want, but this is as far as we need to go for this one. So the final step is to put it all back together and then play a game. Okay, I think that looks really good. That's really cleaned up nicely. Almost all the white marks have gone. There are obviously a few scratches here and there, but this console's not been stored very well. It's been stored in a box for the stuff, so the fact that it cleaned up this well is really impressive. So it's now 2:30 in the afternoon. I'd only planned to spend a couple hours doing this mod, but it's taken most of the day, and that's because of a few setbacks which we'll discuss. But first, let's just take a tour around how it works. So right now, this is in PAL 50 Hz mode. You can tell that because it's blue bars top and bottom. So it's not full screen. To change the mode, you hold the reset button down, and the LED will cycle through the different modes. So red, orange, green. Red is PAL, orange is PAL 60 Hz, and green is PAL 60 Hz Japanese language. So let's do green. So release when you are, and what it'll do is it will switch modes, but it will also reset. So now it should be in Japanese. So if we start the console, and in order to do that, we have to plug the pad into controller 1, because for some reason I keep getting my left and my right mixed up. Right, there we are. So start the game. A real easy way that I've been using to detect what language we're in is to go into original mode on Super Hang-On, and there we are, it's Japanese. You can see all the words they say are Japanese. So that's green. So if we go to orange mode, red, orange, green, red, orange, let go. Now it will reset again. You can see we're in 60 Hz mode because it's full screen, there's no bars. You press start on Super Hang-On. You also tell because the music's quicker. Arcade mode. Here we are. That is pretty much that. Yeah, so a couple of setbacks. Right. The guide for doing this is not written very well. It requires you to actually read 2 other separate guides that are related but don't seem so at the start. So if you Google Mega Drive Switchless mod, or I don't know, if you Google Genesis Switchless mod, maybe you get different results. But if you Google Mega Drive Switchless mod, you'll get the monkey guide. The problem with that one is it's based off 2 other guides that you have to read. So the guides it's based off on are the Switched mod for Mega Drive and the Switchless mod for Saturn. You have to read the Mega Drive Switch mod to understand which traces you need to cut on the board, because there were traces on the jumpers that I'd forgotten to cut until I was quite far along and got quite stuck. So when I cut the jumper traces on the board, then the PIC can control the modes. If you don't cut the traces, the PIC can't override the voltage that's coming directly to those jumpers. So that was hiccup number 1, really. Well, that was more hiccup number 2. Hiccup number 1 was using that bit of perf board. Now, I just didn't check it closely enough. I must have had a short on there or something. It just wasn't working. What was happening was the LED was either in orange mode or it was off. It would never be blue, or it would never be green or red. And so I took the pick out of the board and I put it on a breadboard and I tested it separately. And I didn't record that because it was super boring. But when I tested it separately, it worked fine. So I knew my board was bad. So I ripped the board out and glued the pick directly to the motherboard on a bit of foam and wired directly to that. And that's what we have now, and that works fine. So I'm quite happy with the way that turned out. The final thing you probably need to be aware of is you have to really tune the resistors for the LEDs. So the guide said to put, I think, 220 ohm resistors in for the red and the green. Now, depending on where you sourced your LED from, that might not be good enough. If you've got a cheap LED, it might be that the red and the green diodes need slightly different voltages to kind of appear the same. And that is the problem that we had with this one. So I had to get another resistor in line with the 220, and I think at the end of it, I've still got like a 560 ohms of resistance on that green LED, and to my mind it's still a little bit bright, so I may even have to go up to 800 ohms to darken that LED so it looks a bit better. So on the red one we've got 210 or 220 and that works fine, but yeah, on the green one I think we needed a bit more. So there we go, that's it, that's the video. Thank you very much if you watched this far. These Monday videos, I'm so tired on Mondays for some reason. I really do ramble on. But thank you for watching. I hope you found it useful. Please, if you're going to do this, I recommend you read the guides thoroughly before you start. Don't just jump straight in. This video alone is probably not enough information for you to do it. You have to read those guides. But yeah, hopefully if you're going to mod your Mega Drive, Switchless mod your Mega Drive, find this useful. If you just want to do a Switch mod, we also have a video for that, which I'll link here. There we go. So if you found the video useful, please like and subscribe. Follow us on Facebook, Twitter and Instagram at 16BitBench. Thanks for dropping by, and we'll see you next time.